Alright, this is part 2 of the practice final of the first part of part 2, that is. This is the long answer part. This first question is just basically having you show that you know how to use the one variable stats on your calculator. If you look, I'm trying to drop you a hint here. What I got highlighted in bold letters, oops, I skipped over the V, is one variable stats. One var st a t s. Alright, so there's the one var stats. Alright, so let's just remind you, do the one variable stats here. That's all that you need to do to answer this. If you take the time to do all this by hand, it's just going to take you way longer than you have for the final. So go to your stat editor, put in your data, 15, 26, 18. Alright, and then run your one variable stats. Alright, so what's our mean? 20.73. Alright, round all these to 2 decimal places. So the mean is 20.73. Alright, the median, remember the median's on one variable stats. There's the median, 19. Alright, Q1 and Q3, that's on one variable stats. 16, 26. Sample standard deviation. Sample standard deviation, remember that's back up here at the top. This is sample deviation. This is population standard deviation. We want sample. So 5.65. Alright, sample variance. That's the square of the standard deviation. Alright, that's the only thing that's not on your one variable stats. For that one, you're going to have to square the 5.65. Alright, so 31.92 to 2 decimal places. So the variance is, again, 31.92. Alright, if you had used more of these numbers, like if you would have said 5.650115886, alright, and you squared that, like you actually wrote all it out and squared it, and you got something that rounded differently. These both round exactly the same because of that 0 right there. Alright, but if you got something that rounded different, like say this for some reason would have been 31.93 after we rounded it, then you'd still be given credit. So it's okay to just square your answer for the sample standard deviation if you're asked that for the variance. Alright, upper and lower fences for the data set. Alright, I give you the formula. Alright, so you got Q1, you got Q3 from part C. So all you need to do is just plug those in to that formula. So Q1 was 16. So 16 minus 1.5. Alright, parentheses, Q3 minus Q1. Q3 is 26. Q1 was 16. Alright, close the parentheses, hit enter. So that's 1. So your lower fence is equal to 1. And then your upper fence, same thing, just plug into the formula. Q3 this time that we start off with. So Q3 is 26. 26 plus 1.5 parentheses 26 minus 16. Alright, so we're just plugging in Q3 1.5, Q3 minus Q1, and we get 41 this time. Alright, so there's the lower and upper fence. Using part F, does the data set have any outliers? Right? Outliers are anything lower than 1 from your data set or anything above 41 according to the definition. That's an outlier is defined to be anything above the upper fence or below the lower fence. All right, and again, go back to your data set. The biggest number we have is 33. That's below 41. The smallest number we have is 14, and that's above 1. So we don't have any outliers. All right, so that's how you go about doing problem, or the problem number 1. All it is just, do you understand how to use your one variable stats? And can you navigate through the one variable stats and find all the things that you need to find? All right, the following data set consists of random waiting times sent on Santa's lap at this department store. All right, construct frequency classes with 5 classes starting with 1.5 and fill out the table. All right, so if 1.5 is our first class, then that means that goes in this box right here. All right, so we're going to put 1.5 there. All right, and then when this one ends at 5, we'll just make the next one start at 6, and then it needs to have the same gap as the previous class. So this is going to be 1 to 5, 6 to 10, 11 to 15, 16 to 20, 21 to 25. So that's going to be our 5 classes there. Alright, so now we got all our classes in place. Now we come up with the frequency of how often things occur in each of these classes. Now, there's nothing wrong with, since you're going to have this on a piece of paper, there's nothing wrong with just marking through it and counting as you go. Alright, but there is a feature on your calculator that you can use if you'd like to help you, and that's the sort feature. So we're going to put all our data in here, and then once it's all in, we're going to sort it from lowest to highest. Right? So 12. Okay, so once I have my data in, 21, 4, 8, 9. Once I have all my data in, I hit the stat button, and then I'm going to select sort A. All right, and that's going to take my data set and it's going to sort it from smallest to largest. Alright, I have to tell it where my data is. My data is stored in list 1, so I hit second 1, which again above it, you see it says list 1. And then I hit enter and it'll say done. And now when I go to my back to my list editor, it's broken down into intervals. Okay, so 1 to 5, I have 1, 2, 3, 4, 5, 6, 7 things that fall into that class. Alright, and now the next class, 6 to 10, I've got 1, alright, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. 13 things that fall in this class. And as I go through and fill up all the table with the values, this is what we end up with: 7, 13, 7, 0, 1. Alright, now remember, relative frequency is frequency divided by the total of this column. So I'm going to back out second quit, gets you out of your list mode. Second quit will get you out of basically any screen you're stuck in on your calculator. So I'm going to add up to see how many things I have total. Alright, and I've got 28 total in these things. So I need to divide 7 by 28 for the first and third classes. Alright, so 0.25 for here and here. I need 13 divided by 28 for that biggest class, my modal class. And then just 1 divided by 28 for that other class. Okay, so I'm going to put all those into the table. Alright, and now finally the midpoints. Alright, the midpoints literally are the average of your lower class limit and your upper class limit. So once I do it for the first one and the second one, you'll see the pattern. Okay, so 6 plus 10, if you don't see it already, divided by 2 is 8. Alright, and see, we're just adding 5 every time. So we're going to have 3, 8, 13, 18, 23. Alright, so there's our midpoints. Alright, so there's that table. That's all you're having to do there. Just count how many times something from your data set occurs in each class. and come up with the relative frequency for each one of those. Alright, and then your midpoints. Alright, we got a probability distribution in problem number 3. So we're determining the probability someone uses Wally's service 2 times. So this is, I mean, it's about as easy as it gets. The probability someone uses Wally's steam cleaning service 2 times is 0.07. So 0.07. Alright, that's literally as easy as it's going to get on this thing. Just can you read a probability distribution? Alright, only once. There's 0.22 right beside it. Alright, now, determine the mean of the probability distribution. The mean is the product of this times this, plus this times this, plus this times this, plus this times this. So we could literally do that on our calculator. 0 times 0.68 plus 1 times 0.22 plus 2 times 0.07 plus 3 times 0.03. And that'll give us our mean, 0.45. But there's another way you can do it, especially when I'm looking down there and I'm seeing part E. I have to do the standard deviation. Another way you can do it that's almost as quick is to go into your editor again, put in the values of the steam cleanings in list 1, 0, 1, 2, 3, and then put in your probabilities in list 2, 0.68, 0.22, 0.07, 0.03. And now do your one variable stats. That's how you get a mean. Remember, we get the mean from the one variable stats. But again, remember, if something pops up on your screen and has a cursor waiting instead of just automatically giving you a value, it means it's waiting for an input. So if I tell it list 1, list 2, it understands that it's a probability distribution now, and it does that for you. It multiplies those numbers in list 1 times the equivalent number in list 2 and then adds them all up. So there's the 0.45. Alright, same thing there. But it also gives us the standard deviation there. So that's the big perk of doing it that way. Alright, so I'm going to skip down and do that one real quick. 0.7533 before I interpret this mean, because they can, if you do choose to do it that way, it's going to give you both of them at the same time. So you could just basically answer both of those questions at once. Alright, now interpreting a sentence, interpreting the mean with a sentence. Remember, the mean is expected value. Alright, so Wally should expect the customers who receive his coupon to use his service an average of 0.45 times. Alright, so that's what we mean by the interpretation of a mean. Right? If you have a probability distribution, whatever these numbers represent, the number of steam cleaning services, that's what this is the expected value of. It's the expected value of times people will do this. So Wally should expect the customers who he gave those coupons to use that service however many times that expected value says.